Hey, welcome back to Math with Patrick. Today is July 6th, and we're solving problem number 187 from the Daily Epsilon calendar. And we should show why it looks like x is 6 today, and y is some other number. Because it says, so x and y are elements of the integers. That just means that they are whole numbers, maybe they're positive, maybe they're negative. And then once we find the right integers, we can plug them in here and here. We'll get 4 to the power of some integer plus 2 to the power of another integer. And finally, when we add those two together, we'll get 4,224. One good strategy for these kinds of problems with exponents and bases is to find a common base. So I could rewrite this 4 as like 2 squared and then to the power of x. And then there's just like an exponent rule here that lets you multiply stacked exponents. So I could call it 2 to the power of 2x plus 2 to the power of y is equal to 4,224. And here I am seeing that basically this number is a sum of 2 powers of 2. Other numbers that do this, I don't know, like you could do 16 plus 32. That's going to be equal to 48. And so there's like, other numbers in our number system out there that are sums of 2 different powers of 2. And we just got to find the right one for this kind of large number. I could like divide it in 2 if I really wanted to. Maybe that would be helpful actually. Let's try it out. Let's see what happens. So if I divide this by 2, I'll get 2,112. Dividing it by 2 again, I get 1,000 and then whatever half of 112 is, which would be 56. So we get 1,056. I'm just going to keep going until I can't anymore. Dividing 1,000 in half, we get 500. And then dividing 56 in half, we get 28? So 528. So this would be dividing in half again, 250 plus 14, so 264. This one turns into 132. This will be 66, 33. There we go. So this is the first number that I can't divide by 2 because it's odd. And basically I did 1, 2, 3, 4, 5, 6, 7 twos. So let's bring it back to this original equation. Basically, I just did 2 to the power of 7, or 7 divisions of 2. So I could factor out a 2 to the power of 7. And then now I'm left with, that's supposed to be a 2. 2 to the power of 7, and then times 33 over here for that 4,224. And of course, these two can cancel on either side. And so I'm left with a sum of 2 different numbers that's supposed to get the number 33. And one of these, actually both of these, are still powers of 2. So really the only way for this number to make sense right here, like this number right here, has to be 33. The only way for it to make sense is if we have a 1 plus 32 or a 32 plus 1. And let's see what happens if we try either one and just see what works. Because I'm assuming this is going to be the right answer, but I just want to see what happens if we try something else. So we could have a 1 plus 32 right here. That would require, well, when we expand it back out, that would require this first term to be 2 to the power of 7, because I'm kind of like distributing this 2 to the power of 7 on the outside. And then the other one would have to be, whatever this is, plus 7. So we can, count by our powers of 2, 2, 4, 8, 16, 32. So this right now is 2 to the power of 5. And when we multiply it by that 2 to the power of 7, those exponents add, and we get 2 to the power of 12. Now, looking back to the original problem, we're supposed to have a power of 4 on the left side. And 2 to the power of 7 won't cut it because like this is an odd power, we aren't going to get a multiple or a power of 4 rather we'd need to multiply another 2 in there to make it a power of 4. So what's good though is, like I was thinking, I could just swap these. And so the 32 is supposed to be on the left and the 1 is supposed to be on the right. And so that does mean I get 2 to the power of 7 here, and then 2 to the power of 12 here. And then I can kind of undo what I did earlier to find this expression. I could split my exponent with multiplication. So this will be 2 to the power of 2 to the power of 6, right? Because I could multiply 2 and 6 to get 12. And then this way I can kind of reconstruct that 4 and see that it's 4 to the power of 6 plus 2 to the power of 7. And for this calendar, we're solving for x. We're trying to match x to be today's date. And indeed, x is equal to 6 today. So there's my solution. Hope you enjoyed, and I'll see you tomorrow. Bye.